Okay, now students, in this video we will discuss about the second case of the astronomical telescope, means refracting type astronomical telescope, and the case second is when the image is formed at infinity. Now again, taking the same astronomical telescope, having the two lens system L1 and L2, one is the objective lens, other is the eye lens, and focal length of the objective lens is greater than the focal length of the eye lens. Now in this setup, when the rays coming from infinity, then they will be incident parallel on the face of the objective lens, and we know that when the parallel rays are incident on the convex lens, they will be focused at a point, and the name of that point is the focal point of the objective lens. Therefore, these parallel rays are meet at a point, that is the focal point FO of the objective lens, where the A dash B dash image of the object is formed. And this image, in that condition, if this image is formed at the focal point of the eye lens FE, means these two focal points exist on the same point. FO and FE exist on the same point. Therefore, this A dash B dash will be on the focal point of the eye lens, and again when the ray is incident from this image A dash B dash on the eye lens, so the final image is formed at infinity. So this A dash B dash image acts as an object for the eye lens, and the image is formed at infinity. So this is the case. Now the angle made by the parallel rays with the principal axis, it is alpha. So the interior angle, this angle C A dash B dash will also be equal to alpha, because these are the alternate interior angles. Similarly, the angle made by the A dash B dash on this optic center C dash of the eye lens, say it is equal to angle beta. So the beta angle made by the image, and alpha the angle made by the object on the optic center of the object. So these are the conditions. Now the magnifying power of the astronomical telescope, magnifying power M of the astronomical telescope, it is always equal to the angle subtended by the image on the eye lens to the angle subtended by the object, that is alpha, is known as magnifying power. So the definition of the magnifying power in that case can be defined as the angle subtended by the image at the eye when the object is placed at infinity, and the angle subtended by the object at the eye when the image is formed at infinity. Meaning in both the cases the image and object will be placed at infinity. So it is the ratio of the angle subtended by the image to the angle subtended by the object when both are placed at infinity is known as magnifying power of the astronomical telescope. Now M equal to beta upon alpha, since angles are very small, they will be replaced by their tangents. Now it is equal to tan beta upon tan alpha. Again we have to find out the value of the tan beta. Now tan beta in triangle A dash B dash C dash, A dash C dash A dash B dash, what is about the tan beta? Now tan beta will be equal to this perpendicular upon that is base upon perpendicular upon base, so A dash B dash upon C dash A dash. So A dash B dash upon C dash A dash. Similarly in triangle this C A dash B dash, C A dash B dash, again find out the value of tan alpha, and tan alpha equal to A dash B dash upon C A dash, this C A dash. Now put the value in the equation number 1, we will get M equal to, that is A dash B dash upon C dash A dash into tan alpha. Now inverse the value C A dash upon A dash B dash, and this A dash B dash term is cancel out, and we will get C A dash upon C dash A dash. Now in this formula, by using the new Cartesian sign convention, so C A dash according to new Cartesian sign convention, that is C A dash that is equal to FO, and it is taken as positive. Now because it is distance is measured in right side from the optic center. Similarly C dash A dash, this is equal to the focal length of the eye length, but distance is measured opposite to the optic center, it is equal to minus Fe. So the magnifying power in that case will be equal to plus FO upon minus Fe, that is equal to minus FO upon Fe. So this is the magnifying power of the astronomical telescope when the image is formed at infinity. I hope that you have to understand the very easy topic, and next part will be discussed in the next video. Okay, thank you very much.